Hello everyone, welcome to Study UTech. This is solution of transformer MCQ questions. If you haven't watched the previous video, please watch it because many MCQs were there which are important. Okay, let's start. The first question is the operation of a transformer is based on mutual induction. Transformer is a mutually inductive device. Okay, so the primary coil and the secondary coil, they are mutually connected via this magnetic flux. This is a primary, this is a secondary, and this is the flux. Okay, so phi, so it is a mutually inductive device. Okay, next, the regulation of a transformer is negative, the load in the secondary side is, remember, if the load is lagging, voltage regulation is positive. For unity power factor, voltage regulation is also positive, but voltage regulation can be zero or negative. That is only possible if the load is leading. It can be zero or negative. Okay, so remember this one. Okay, next question. It is saying the iron loss of a transformer is 100 watt at half load. At full load, the iron loss will be. Look, the two losses are there in the transformer. One is called the I square R loss or the copper loss. Okay, another is the iron loss, Pi or iron loss. Iron loss is the loss which happens in the core of the transformer. That is the iron. That is hysteresis loss and eddy current loss. Okay, these two laws are constant. Constant if the load is changing. Constant means they are independent of load current. So the answer will be, it will remain as half load or full load, the iron loss will remain constant, so 100 watt. What is the next question? In a transformer, the flux phasor, look, assuming the flux to be phi m sine omega t, okay, so you will get the to derive, if you derive E1, E2, you will get n d phi dt. Okay, so you will get, it will be sine 90 degree phi m sine, sorry, if you derived E1, you will get E1 max sine omega t minus 90 degree. What does it mean? Drawing the phasor diagram of the transformer, mutual flux phi m, and you will get here, this is E1 and E2. If N1 is equal to N2, then E1 will be equal to N2. So it is lagging. The flux is leading, E1, E2 is lagging. So they are asking the flux phasor. In a transformer, the flux phasor leads the induced voltage, lags the induced. You can see from here, it is leading. Phi m is leading E1, E2. Okay, so it leads the induced EMF by 90 degree. Okay, next. Next, in a transformer, zero voltage regulation at full load. Well, I told you the voltage regulation can be zero or can be negative only if the load is in leading power factor, capacitive load. Okay, so this will be the answer. We can explain this thing. Okay, but before, let me finish. Can a transformer be used for 25 Hz with input voltage rated for 50 Hz? Look, this will be the answer. A transformer, basically this is the transformer, you know, and there is the coil. So what you give here? V1, right? What the voltage induced here? E1 will be 4.44 phi Fn. Okay, so this will be the induced EMF equation, and resistance is negligibly small, assuming we can say this is nearly equal to V. So what will happen? I am not changing the voltage. If I only make the frequency half, the phi will be double. Okay, so you can see if it is half, it will be double. If the V1 is constant. So what will happen? The flux will be doubled, which will drive the core to excessive saturation. So excessive saturation means the flux will there is a linear region for the flux, and this, if this is a flux and this is a current, there will be a nature will be something like that. So this will reach to the non-linear portion. We have to keep in this linear portion. Okay, so this is the answer. Okay, so we can discuss about the voltage regulation here. That point I need to make a bit what to say, the more discussion. The transformer equivalent circuit we can draw, but the voltage is induced here E2. Okay, then the resistance, then the inductance. Okay, so this will be the V2. Let's say some load has been connected to it, so the voltage is V2. This is RE2, this is XE2. Okay, so this portion is induced voltage. When you connect the load, some current flows through this one, you get the load voltage here. So this difference E2 minus V2, this is a voltage regulation actually. Okay, so we can explain these things from phasor diagram. Drawing the phasor diagram, it will be like this. Look, starts from here. I can start from V2. Okay, this is V2. Okay, let's say is a lagging load is connected, so I will be in this direction, I2. Then I have to add this voltage drop to get E2. Okay, so adding this, let me take different color. This will be in parallel to I2 RE2, and 90° to it I2 XE2. Okay, so we get the E2 will be this one, right? This will be a straight line. Forgive my drawing. E2. Okay, so this is the triangle, you see it. This is the triangle. Okay, so difference is what? The E2 length will be, you can see from here. Look, this is I2, and if I change this angle, this is a theta to assume. If I increase the angle, what will happen? This triangle will move in this direction, Okay, so then E2 will be more flat. It will be in this direction in that case. But not any instant, and I mean every instant, E2 will be greater than V2. So the voltage regulation will be positive. Okay, so as you increase the theta in this direction, that will not make your E2 lesser than V2 or equal to V2. Okay, so increasing angle in this direction, meaning you are increasing the lagging load. Okay, so now if unity power factor, what may happen in unity power factor? If it is a unity power factor, what can happen? This is your V2, this can be your I2. Okay, so this will be I2 R2, I2 R2 RE2 actually. Then this will be the X2, I2 XE2. So this will be your E2. Now look, E2 is not less than or equal to V2. This is not also possible. Unity power factor not possible. Lagging power factor not possible. Only if it is leading power factor it is possible. Let me show you. So let's say this is V2. The leading power factor means this will be I2. Look, this will be I2. Now you have to, in parallel to V2, you have to draw I2 RE2. Okay, then there will be I2 XE2, and that will be, this may not collide, but somehow I have done that. So this is equal to E2. So this means E2 may be this direction or that direction. It will not be in line with E2, I2. Okay, so this may happen that this length V2 and this length E2 may be equal, and depending on the load current, if it increases more and this angle increases more, maybe E2 lesser than V2. So in leading power factor, your voltage regulation may be 0 or negative. Okay, so that thing I told you extra, you can remember all these things, that may help you. Okay, so this is the end of our part 2 portion. Okay, hope there will be another lecture on part 3. Okay, so some other numericals will be there, and MCQs will be there. Okay, hope you have liked the video. Please share among your friends and subscribe the channel and press the bell icon to get the notification for further video update. Thank you.